Good afternoon, class, and good afternoon. We'll review some of the concepts we've seen this week as far as reactions of chemicals. Let's begin with the first one, synthesis reaction. In synthesis reaction, what you end up with is one product. You have two beginnings, such as H2 plus O2, for example, two reactants, and one product. You're combining two things into one. If possible, three things into one, when allowed. Something like this goes on. Balance the equation. You have two H's on my left, two H's on my right. That's good. O's is not balanced. Now we're all good. So to summarize things, synthesis reaction is the combination of elements. Elements is what makes a synthesis reaction. We can go ahead and continue with more examples, such as, let's go with gold. Let's go with aluminum instead. Aluminum plus phosphate. We get a combination of Al, PO4. Let's be careful with the charges because phosphate is a charge of 3. So is aluminum. So those charges just go away. Let's do another one. Let's work with aluminum again plus hydroxide. Let's combine those. We do end up with Al and OH. That is true. However, the charge of aluminum, as we know, is 3. The charge of phosphate is 1. Therefore, what's going to happen is the 3 will go to the OH. This equation is not yet balanced. Let's continue here and do a 3 here. And now we're balanced. There are occasions in which you're giving words instead of symbols. Sodium and carbonate, for example. Yields something. Well, let's use common sense. Sodium is Na plus carbonate. If I look at my chart, carbonate should be CO3. Let's make sure of that. Okay, we found it. Good. CO3. Still in synthesis. So we end up with Na, CO3, charge of 2 on carbonate. Therefore, the 2 goes to sodium. Simple equation. Next one, combustion reaction. It is actually the addition of oxygen to an equation. If we look at a simple question we saw earlier, we have hydrogen plus oxygen. The fact that I have plus oxygen makes it a combustion reaction. Yields something is even off. Therefore, H2 diatomic element plus O2 diatomic element gives you H2O. Besides being a synthesis reaction, it is also a combustion reaction. Let's balance this out. 2 over here, 2 over there. We're good now. Let's make sure that we review a little bit over here. Synthesis, so far is good. Combustion, addition of oxygen. Let's do another combustion reaction. C2H4 plus O2. As long as I have oxygen adding to the equation, it is combustion reaction. I end up with CO2 plus H2O. Let's balance this equation over here. I have 2 C's on my left, 1 C on my right. Okay, let's go over here. Okay, let's continue with this. I have 4 H's on my left, 2 H's on my right. Okay, let's continue with this. So C is good, H is good. My oxygens, I have 2 on my left, and I have 2 times 2, 4, and 2, 6. Let's do a 3 over here. Now the equation is balanced. Important about this equation, this is alcohol. Combination of C and H alcohol, and this of course is oxygen. So we have the rule that when an alcohol gets combusted, CO2 and H2O are given off. Let's try another one just to make sure we follow that ruling. Let's continue with C3H6 plus O2. That will give you same result, CO2 plus H2O. Go ahead, balance the equation, and you should be okay on the equation. Next one. Decomposition is the breaking down of a compound. Simple equation again. I could go back from synthesis. It is the opposite of synthesis. If I go H2O decomposes to end up with H2 plus O2. That's the equation. And I have 2 here, 2 there is balanced. There are certain rules. For example, the decomposition of a metal with carbonate. We saw earlier that carbonate had a specific charge of 2. If I look at aluminum carbonate, breaks down to form something. Okay, the rule is that when carbonate decomposes, metal carbonate decomposes, I will always end up with the same type of result. Not the same result, but the same type of result. Aluminum, Al, carbonate, CO3, exchange those charges. Just 3 there, 2 there. This breaks down to give me aluminum oxide. These 2 on Al came from oxygen, and the 3 from O came from aluminum, plus CO2. If we go ahead and balance this equation, we end up with 3 here, and we're good. What happens from this ruling is that when metal carbonate breaks down, we end up with metal oxide and carbon dioxide. Good. Let's continue. Another example of this will be Na2, CO3. I again have a metal and a carbonate. Breaks down to give me NaO, Na2O plus CO2. If the equation is not balanced, balance it. Let's check it out. Before the arrow I have two NAs. After the arrow I have two NAs. That's good. Before the arrow I have one C. After I have one C, that's good. And before the arrow I have three O's. After the arrow I have three O's. That is balanced. Let's continue. Single replacement. All we're doing here is switching one element for another. The lone element, whether it is a metal, whether it is a non-metal, will be replacing another one. This list shows the most reactive to the least reactive element. An element at the bottom cannot replace any element higher. No replacement. No reaction. However, an element at the bottom, yes, can be replaced by anything on top. Just one example. It's over. And we go with, just to give it a try, we go with calcium chloride plus lithium. As I could see on this equation, the lonely element is lithium, and lithium is trying to replace the other metal. I will have to end up with a metal and a non-metal combination, because I'm giving first a metal, non-metal.
Please pardon this interruption. This is an announcement for those students who were handed the information.
I'm given a metal and a non-metal first. I should end up with the same type of combination. So let's try this. What's going to happen is this lithium is trying to replace the other metal. Is that possible? If lithium is higher than the other element, yes. In this case it is. Therefore, I will have a recombination. Lithium will end up with calcium. Chlorine is my apologies. We have lithium chloride plus calcium alone. There are occasions in which the metal or the element cannot replace the other one. Let's try this. Calcium chloride plus lead. If I look at the chart, lead is lower, lead is here, and calcium is here. Therefore, calcium is more reactive, and you get a no reaction. The lower element cannot replace the higher one. Lead is here, calcium is there. Another example. Let's work with some gases over here. Let's use the same example. Calcium chloride plus fluorine. The question is fluorine a diatomic element? According to our list, it is a diatomic element, so it becomes F2. Next question. This is a non-metal fluorine, trying to replace this other non-metal. If fluorine is higher than chlorine, it could be replaced. I go here and I could see that fluorine is higher, therefore more reactive. I end up with metal and a non-metal. Trying to write the word again. CAF 2, because calcium is charge of 2, plus single chlorine diatomic element. Balance those equations. You should be good now. Double replacement. We could get so many different combinations, and when we have double replacement, we don't have to be concerned with the list of reactivity. Things will just change. Example of that, we get NaCl plus, just to give two other elements, let's call them magnesium nitride. This is all we get for the equation. What's going to happen is this metal will combine with the opposite non-metal. Opposite non-metal. So this metal will go with that non-metal. Therefore, we end up with Na3N, sodium nitride. What's left over is this metal charge of 2 with that non-metal charge of 1. Sodium nitride plus magnesium chloride. We could go ahead and balance this equation. Let's move this over, because that is not part of my equation. That's just to help me out. Okay, let's balance the equation. I have 2 NAs, 1 NA on my left, 3 NAs on my right. Let's go ahead and put a 3 at the beginning here. I have now 3 sodiums on my left, 3 sodiums on my right. Chlorines, I have 3 on my left, I have 2 on my right. That is not correct. So let's go ahead and do a 3 here. If I'm doing this correctly. Okay. What's happening here is that something is not working out, because I have now 2 magnesiums here, 3 magnesiums on my right, 3 on my left. That is true. However, chlorines, I have now how many chlorines on my left, how many chlorines on my right? That is not working out. Let's try it again. Let's go from scratch. 1 Na on my left, 3 NAs on my right. Let's do that one last. It's just throwing us off. Nitrogens. I have 2 on my left. I have 1 on my right. Let's try. Let's give that a try. See how we end up with. 2 here. My nitrogens, which is the N, is 2 on my left, 2 on my right. That is good. My sodiums are now 6 on my right, 1 on my left. Before the arrow, after the arrow. Let's try a 6 over here. 6 sodiums, 6 chlorines. If I try a 3 over here, okay, what's going to happen is sodiums 6 on my left, sodiums 6 on my right, chlorine 6 on my left, chlorines 6 on my right, because I have 3 times 2, 6 chlorines. Okay, I have magnesiums 3 on my left, 3 on my right, nitrogens 2 left, 2 on the right. We are good. This is a balanced equation. What throws students off most times is the words. Word equation, that you get confused because you don't know what to do on the words. It is easy when you have symbols like this one. Everything is symbols. NaCl, Mg, and N. However, words. Iron 2 carbonate combines with aluminum sulfate to give you a reaction. Understand something. You have a positive here and you have a negative. You have a positive here and you have a negative. Let's go back to what we know from earlier. This positive will recombine with the opposite negative, and this positive with the opposite negative. Double combination. Let's do the symbolic equation now. Iron is Fe, carbonate CO3. They are both charged of 2, so they cancel out. Plus aluminum, Al, sulfate, SO4. Sulfate is charged of 2, goes to aluminum. Aluminum charged of 3 goes to sulfate. I get a reaction. I must end up with a positive, negative, positive, negative. Iron goes with sulfate. Fe, SO4, both charged of 2, they cancel out. And aluminum goes with carbonate, and they will exchange those charges. The CO2 has a charge of 2, goes to aluminum. Al charge of 3 goes to carbonate. Let's go ahead and balance the equation. Fe is 1 on my left, 1 on my right. That is good. What is off right now is my sulfate. Okay, so I have 3 sulfates over here. Let's do a recount. Fe is 1 on my left, 3 on my right. Okay, 3 Fe's over here. There you go. Let's see what we have now. 3 Fe's on my left, 3 Fe's on my right. CO3 is 3, CO3 is 3, Al is 2, Al is 2, SO4 is 3, SO4 is 3 on both sides, and you have a balanced equation. When you have a word problem, the only thing that you have to do is go to your table, go to your chart, and write down the symbols, whether it is an element, whether the single element, whether it is a polyatomic ion, metal, non-metal. You have the chart with you. All you have to do is go to the chart, look at the name, match the name with the symbol, write that down. Then what you have to do is decide, is it a synthesis reaction? Am I going to decompose a reaction? Am I going to do a single replacement, double replacement? Is this a combustion reaction? Once you have that figured out, it will be much easier for you to continue with the equation. I hope this helps.